Hi everyone, welcome to my channel Mean Gummy Lizard. I'm glad you're here. So sit back, enjoy the video and let's build something awesome like this little droid here, which solves a very real problem. My wife runs a go-kart business and sometimes guests who have been drinking are not noticed at the counter. By the time the staff noticed it, at the track entrance, the ticket has been sold, the waiver has been signed, and everything has been processed. Since we have a really strict zero alcohol policy for safety and insurance reasons, anyone who has been drinking cannot be allowed to drive. So I decided to build a small helper. And because I am a huge Star Wars fan, I didn't want to build just another boring sensor box. I wanted to turn a useful everyday device to something with a sci-fi inspired look. So in this video I'm building an alcohol-sniffing droid. So let me show you how I made it.
Before we start building, let's quickly look at the main components. The ESP32 is the brain of the device, maybe a bit overpowered for now, but it gives us plenty of room for future upgrades. The most important part here is the MQ-3 alcohol sensor. It reacts to alcohol vapors in the air and gives us the basic measurement. To guide the air towards the sensor, I'm using a small 12-volt fan. Since the ESP32 needs 5 volt, I use a step-down converter to power everything from one 12-volt power supply. The fan should not run over it all the time, so I added an IR proximity sensor. When someone comes close, the ESP32 activates the fan through a relay and starts the measurement. The result will be shown with LEDs on the back of the device, so the warning stays discreet. That's the basic setup. Detect the person, pull in air, measure alcohol and show the results. Before building the final device, I want to make a simple test setup on a breadboard. For this test, I'm using a breadboard, 2 5K resistors, 1 20K resistor, and for sure the MQ-3 alcohol sensor, and 3 LED lights and the ESP32. The LEDs give me a very basic visual output. Green for low values, yellow for medium values, and red for high values. Now, one of the important parts of this setup is the voltage divider. The MQ-3 sensor can output up to 5 volts, but the ESP32 input pin should only receive about 3.3 volts. To reduce the signal voltage, I'm using 2 resistors. A voltage divider is a simple circuit made from 2 resistors. One resistor is connected to the sensor signal, the other one to the ground, and the ESP reads the voltage from the middle point. The formula is very simple. It is voltage out is voltage in multiplied by the resistor 2 divided by resistor 1 plus resistor 2. And in my case, it is I use a 10K resistor. These two 5 volts are 10K for R1 and 20K for R2. So the calculation is 5 volts multiplied by 20K ohm divided by 10 kilo ohm plus 20 kilo ohm. And this result is then 3.33 volts. That means the 5 volt sensor signal is reduced to about 3.3 volts, which is much safer for the ESP input. So I don't want to fry my ESP32 input. So yeah, we're going with that. And now I'm writing a little bit of code, quick and dirty, upload it to the ESP32 and let this little piece of technology suffer.
With the basic electronics figured out, it was time to design the housing. I created the entire droid in Onshape, which is a great CAD program for beginners because it's relatively easy to learn and works directly in the browser. Here in the assembly view you can see the individual parts coming together one by one, from the base and body panels to the internal mounts and finally the lens. The goal was to create something compact, functional, while giving it the character of a small sci-fi droid instead of just another boring electronics box. Once the design was finished, it was time to bring it into the real world. One by one, all the 3D printed parts were ready, and now the droid could finally taking shape. For the lighting behind the lens, I'm using individual WS2812B addressable LEDs. These LEDs are perfect for this project because each one can be controlled separately. That means I'm not limited to single color or a simple on and off effect. Later I can create animations, warning patterns, scanning effects, or whatever else seems appropriate for a small sci-fi droid. And because I'm using individual LEDs instead of ready-made strip or rings, I can position them exactly where I want them behind the lens. The downside is that every LED has to be connected by hand. Each one needs power, ground, and a data connection. The data signal also has to travel in the correct direction, from the output of one LED to the input of the next one. And because these components are quite small, it requires a little patience and a reasonable steady hand. I first prepare the wires, tin the contact pads, and then solder the LEDs together one by one. The connection need to be short enough to fit inside the housing, but still flexible enough to arrange everything properly behind the lens. This is definitely one of those jobs that looks simple until you actually start doing it. One slightly misplaced wire, one bad solder bridge, or one LED connected in the wrong direction and the entry chain may stop working. So after connecting a few LEDs, it's always a good idea to check the wiring before continuing. It is much easier to find the problem now than after everything has been glued into the finished housing and arranged in the complete droid head. The final arrangement should distribute the light evenly across the lens without creating obvious bright spots. The lens itself will help diffuse the light, but the position and spacing of the LEDs still make a big difference. It takes a little time, but once all the LEDs are connected, the droid finally gets something every proper sci-fi machine needs: a completely unnecessary but extremely important dramatic lighting. For detecting when someone approaches a droid, I originally planned to use a simple IR obstacle sensor, but during tests I decided to replace it with a time of flight sensor instead. It measures distance using light and should give me a more reliable and precise result. Before I install it, I first need to solder the header pins onto the board. This is only a small step, but an important one, because this sensor will tell the ESP32 when someone is close enough to start the fan and begin the measurement. The next set of WS2812B LEDs goes onto the backplate of the droid. These LEDs are not just decorative. They will be used to display the detected alcohol level in a simple and discreet way. The idea is that the front of the device stays relatively neutral until it detects a really high amount of alcohol, then it goes berserk, while the staff can read the results from the back. Depending on the sensor value, the LEDs can change from green to yellow, finally to red. Green means the reading is low, yellow indicates that the value is rising, and red means the sensor has detected a much stronger alcohol signal. Because these are individual addressable LEDs, I can control every light separately. That gives me much more flexibility than using standard LEDs, and it also allows me to add smooth transitions or small animations later on. Just like with the LED behind the lens, each one needs power, ground, and data connection. The direction of the data signal is important, so every LED has to be connected in the correct order. I'm soldering directly onto the backplate so they stay in the right position and line up with the openings in the housing. The solder joints need to remain compact because there's not much space once the electronics and the wiring is installed. When this section is finished, the backplate becomes the Droid status display. Simple, visible to the staff, and hopefully much less dramatic than a yellow warning light goes off, or something like a siren, or something like that. With all the printed parts prepared, it was time to get them ready for painting. I laid everything out and applied a coat of primer. This helps the paint stick better, hides some of the typical 3D print textures, and gives all the parts a clean and even surface. Now the Droid is finally ready for its colors. Now it was time to give the Droid its final appearance. I started by applying the base colors to one section of the outer shell. For this design I wanted a slightly worn industrial look, something that feels like a functional machine rather than a freshly manufactured plastic toy. The primer gives me a good surface to work on and also makes it much easier to build up the different colors. Of course, every printed part has to go through more or less the same printing process, but watching me paint every single panel would probably be a very effective course to insomnia. So instead of showing the entry process, here are all the finished parts. The combination of dark surfaces, metallic details and a few constraints accents gives the Droid much more character. Some additional weathering and small imperfections also help the typical appearance of a, let's say, the Star Wars style, the used sci-fi style. Now everything is painted, the individual pieces finally look like a part of the same machine, and the final assembly can begin. Before assembling the Droid, I need to prepare the mounting points. Instead of screwing directly into the printed plastic, I'm using threaded inserts. These small brass inserts are melted into the parts and provide a much stronger and more reliable metal thread. This is especially useful for a prototype like this because I may need to open the housing several times to adjust the electronics, replace the components, or fix something that definitely worked perfectly 5 minutes earlier. And because I am the mean lizard of the future, I can tell you that I opened that damn thing several times. Yeah. To install them, I first positioned the insert above the prepared hole, then gently heat it up with the solder iron and slowly press it into the plastic. The important part is to use enough heat and pressure. If the insert is pushed too quickly, it can go in crooked or damage the surrounding plastic, and if the soldering iron stays there for too long, the mounting point may start to look less like engineering or more like modern art. Once the insert reached the correct depth, I removed the soldering iron and let the plastic cool down around it. This creates a strong, really strong connection that can handle repeated assembly, but better than a screw driven directly into the printed material. I repeat this process for all the mounting points across the housing. With the thread insert, the different section of the Droid can finally be screwed together securely while still remaining easy to open for maintenance and future upgrades. Yeah, after installing all the screws, now we have to implement all of this here. This is the complete electronic with the alcohol sensor, the ESP32, the eye, the back indicator for the alcohol level, some switches, a little bit of a small buzzer to give a little bit of a sound response, the relay for the fan, and then we have the step down module here. We have also we have to implement. Then I have here a pin out for the ground. I have a pin out for the 5-volt voltage here. So we have all this we have to integrate now in
in the 3D printed construction of the alcohol detection nose droid, whatever it is. Right now I cannot tell you what this is, or yeah, I can tell you what it is. This is an alcohol detection device, but how I will call it, I don't know. We will see. I don't want to solder the ESP32 directly onto the perf board, because I may need to replace it later or use different boards in a future version. So instead, I'm using 2 rows of female headers. The ESP32 can simply be plugged in and removed whenever necessary. The problem is keeping both headers rows perfectly straight up, parallel, and so that they are not tipping over while soldering them in place. If they move or tilt, the ESP32 may no longer fit into these headers. To make this easier, I designed and printed a small soldering jig. It holds the headers straight up in the correct position while I place the perf board on top. This keeps everything straight and prevents the headers from slipping, tipping while I solder. It also helps me work faster, so I don't have to keep the soldering iron too long on the point to risk melting the plastic. A simple little tool, but it makes the whole process much cleaner and easier. Underneath the ESP32, I'm adding a simple voltage divider. The MQ-3 sensor can output up to 5 volts, but the ESP32 input is designed for about 3.3 volts. The resistors reduce the signal to a safe level before it reaches the input pin, protecting the ESP32 while still allowing to read the sensor values correctly. Now that the prototype has done its job, it's time to take everything off the breadboard and prepare the electronics for the final assembly. And if you have made it this far in the video, thank you so much for watching. If you enjoy projects like this, please like the video and subscribe to the channel. It's really helping the channel to grow. And it also tells the algorithm that some crazy people actually want to see more strange little sci-fi machines like this. So again, thank you for watching, liking and subscribing. It really makes a big difference. Now I am assembling the airflow system for the alcohol sensor. The air first enters through the intake at the front of the droid. Behind that sits the mounting plate, followed by a fan, which pulls the air into the housing. After the fan, I added a spacer with an air outlet. This is important because the air needs a clear path through the system. Without an outlet, it would simply collect inside the housing the air, and the sensor readings could become slow and unreliable. At the end of the airflow path sits the MQ-3 alcohol sensor. The idea is to guide a fresh air sample directly across the sensor instead of relying on random air movement around the device. This should make the response faster and more consistent. At least that is its theory. Airflow has a habit of looking very simple in CAD and then doing something completely different in the real world. You know, physics and this whole stuff. So the intake fan, vent and sensors all need to be lined up properly and create one continuous path through the droid. Once everything is assembled, the fan can pull air in, move it past the MQ-3 sensor, and then release it through the vent instead of trapping it inside the housing. Next, I'm mounting the MQ-3 sensor onto its holder and attaching it to the center plate of the droid. This keeps the sensor firmly in position and makes sure it stays aligned with the airflow system I assembled earlier. A stable mounting point is important because the sensor should not move around once the housing is closed. At the same time, I'm installing the time of flight sensor on the front plate for the first time. This sensor detects when someone approaches the droid and tells the ESP32 when it's time to start the fan and begin measurement. So with the MQ-3 secured in the middle and the TOF sensor mounted at the front, the droid is starting to get both its senses of smell and its awareness of the world around it. So this is where I run into the typical problems of designing before having the actual component in hand. The first front plate looked fine in CAD, but after installing the TOF sensor, I noticed that part of it was covered by the housing. Even after correcting the opening, the surrounding design still partially blocked the sensor field of view. So I had to go through several iterations, redesigning the front plate, printing it again, testing it, and then making more changes. In the final version, I removed the problematic design elements and gave the sensor a complete clear field of view. The lesson here is simple. Whenever possible, have the electronics in front of you before designing the housing around them. Data sheets dimension are useful, but the real component usually tells the full story. It cost me extra time and several prints, but I learned a lot from this process. Next, I'm mounting the ESP32 perf board onto its holder, and this keeps the controller and the surrounding electronics securely in place and makes the whole assembly much easier to install inside the droid. With the board mounted, another major section of the electronics is ready for final assembly. Next, I'm mounting the relay for the fan and the step-down converter onto the holder. The relay allows the ESP32 to switch the 12-volt fan on only when a measurement is needed. The step-down module reduces the 12-volt power supply to 5 volts for the ESP32 and the other low-voltage electronics. Mounting both components on a dedicated bracket keeps the wiring organized, prevents them from moving around inside the housing, and makes the final installing much easier and cleaner. Now I'm attaching the support ring to the bottom of the droid. This ring forms the connection to the stand and gives the finished device a stable base. It may look like a simple part, but it's important that the droid stands securely on the counter without tipping or moving around. With this mounting ring in place, the housing is ready to be connected to the final stand. Next, I'm attaching the front panel to the outer shell of the droid. With this panel screwed in place to the upper hull, it looks starting to look much more complete, even if it isn't right now. There's so much more work. Now I'm mounting the air intake and the illuminated lens onto the front plate. The intake guides the air to the internal fan and the MQ-3 sensor, while the lens becomes the visual focus of the droid. Behind it, the WS2812B LEDs will provide the lighting effects and give the front much more character. With both parts installed, the droid, gets its face. After quite a bit of wiring, everything is finally connected. And a quick camera transition later, and the Droid is almost fully assembled, with the back hull still open so I can test every connection before I'm closing the housing. And here it is, the finished alcohol-sniffing Droid. The housing is assembled, the electronics are installed, and the backplate displays the current status of the system. When the drawing starts, it runs to its own startup sequence. The light, sound, sensor and the fan are checked before the device becomes ready for use. From this point, I would let the different startup sequences play without additional narration, so you as a viewer can hear and see the Droid working from several angles. The time-of-flight sensor detects when someone approaches. The fan pulls an air sample through the intake, guides it across the MQ-3 alcohol sensor. The illuminated lens at the front shows that the Droid is active, while the LED on the back provides a discrete indication of the measured alcohol level. Now it's time to see what happens when the sensor detects a much higher concentration of alcohol. For this test I'm holding a cup containing isopropyl alcohol in front of the air intake. As the concentration rises, the warning level increases, the front lens turns red, the LEDs on the back react, and the Droid activates full alarm sequence. I may have made the alarm slightly dramatic, but to be fair, this is a sci-fi Droid, a quiet little notification would hardly be appropriate. For the final test I'm using a glove with a small amount of alcohol and moving it near the intake. This shows the complete process again: detection, air sampling, measurement, visual feedback and alarm response. And with that, the first version of my alcohol sniffing Droid is complete. It is still a prototype, and there's several things I may improve in the future, including calibration, the airflow, the detection logic, but the basic system works, and I learned a lot while building it, especially when it comes to CAD design, and I have a real problem with wiring. So these DuPont jumper cables are not really a solution for that. I opened that guy several times, and on the next day I want to turn it on, and again doesn't work, because some of these jumpers thought, oh, I'm getting loose, I'm free. I don't know. So in the future I will integrate in my designs even a cable management, or I'm doing my own PCBs, so that this is not happening anymore, and it's so much wires in there that yeah, it's a little bit difficult to handle if there's an error. So yeah, But if you enjoyed the video, please leave a like and subscribe to my channel, Mean Gummy Lizard. It really helps the channel and tells the algorithm that you would like to see more of these little crazy sci-fi machines, strange looks and unnecessary little droids. Thanks again for watching, and I'll see you in the next project.